Hey there, science enthusiasts! Have you ever wondered how complex life on Earth came to be? Let's take a journey back to around 700 million years ago, during a time known as Snowball Earth. Picture this, our planet covered in ice, from the poles to the equator. These massive glaciers weren't just sitting there looking pretty, they were on the move, acting as powerful geological brooms. Imagine glaciers as enormous bulldozers, grinding up ancient rocks and releasing essential minerals like phosphorus and iron into the oceans. As these glaciers advanced and retreated, they pulverized rocks, sweeping the planet's crust clean and dumping vast amounts of nutrients into the seas. This process, called ocean fertilization, dramatically changed seawater chemistry. Suddenly the oceans were teeming with nutrients, a perfect setting for life to thrive. Photosynthetic microorganisms like ancient algae had a field day. They multiplied like crazy, pumping oxygen into the atmosphere and oceans. This oxygen boost was a game changer, creating an environment ripe for the evolution of more complex life forms. But how did Snowball Earth come to be in the first place? Well, it started with a drop in atmospheric CO2 due to rock weathering on a large tropical continent. Tectonic activity also played a part, creating shallow seas that absorbed even more CO2. The advancing ice sheets reflected sunlight, causing temperatures to plummet further. Eventually, volcanic activity saved the day. Volcanoes released CO2, which built up in the atmosphere because the ice had reduced geochemical cycling. This led to a greenhouse effect, warming the planet and melting the ice. The Great Thaw caused rapid sea level rise, dumping even more nutrients into the oceans. Recent research, like a study published in 2025, analyzed glacial sediments in Scotland and Ireland. It showed increased erosion and downcutting linked to glacial activity, with sediment redistribution after the glaciers retreated. This research suggests that these changes in continental weathering contributed to significant geochemical shifts during the Neo-Proterozoic era. Rather than being a purely hostile period, the Neo-Proterozoic era might have been a catalyst for the biological complexity that defines our planet today. The glaciers' retreat shaped the distribution of elements critical to ocean ecosystems, setting the stage for the burst of life during the Ediacaran period. So next time you think of glaciers, remember their role as Earth's ancient architects, paving the way for the complex life we see today. Thanks for watching, and stay curious.